we're going to learn. We're going to see something like this, and how do you know when you're fully reduced for something like, let's say we had 5a squared b minus 5ab squared divided by 50a cubed b. How would you know if you're reduced or not? We're going to talk about that. It has to do with lowest common multiple, right? No, greatest common factor. You look for the greatest common factor for all the terms. If there's a greatest common factor between all of them, that's what you divide out. That's how you know. We'll do one right now. Then we're going to do long division for polynomials. Because, yeah, that's what we're going to do. Long division for polynomials. So that's going to be something like if you had, I don't know, 3x squared minus 2x plus 5 divided by 2x minus 1 or something. Okay? This one's probably not one we're going to do. You have to be very careful with these when you make up practice problems. But, yeah, we're going to do long division. And you know how long division works if you did 383 divided by 11? You know how the top number would go in the house? And you do that, right? And you would say, oh, how many times does 11 go into 38? And then you'd multiply, and then you'd subtract, right? And then how many times does 11 go into that? 4, and then right? And you'd subtract, and you get 9, and then your remainder would be 9. So we're going to do that kind of division with these. Make sense, Mr. Flowers? It's going to be fancy. Man. In synthetic division, it's kind of different. If you were dividing by something that was just x plus or maybe minus a number, there's a shortcut, a way that's faster. So you would put the opposite number here and then just the coefficients. And that's 19, and then I don't know what 7 times 19 is. Oh well. So, wait, what's 7 times 20?
140.
140. So this would be 7 less than that, right?
Mm-hmm.
Yeah. And yeah, so you'd add those together, 138, and this would be your remainder. That's what we're going to see right now. We're going to learn how to do all that. Whoa, you ready?
No.
Buckle up, Buttercup. Too bad. Here we go. Oh no. Goodness gracious. So the first topic is reducing, right? Reducing. How do we know when we're done reducing something like this? So here's the idea. I'll put it in words. I'll write it underneath. You're reduced when there's not the greatest common factor for, and this is a key word right here, all terms. If there's a greatest common factor for all of but one of the terms, it doesn't matter. So this is the key idea right here, and let's see what that means. Mr. Flowers, you ever been, or Edgar, you ever been like confused by something? Somebody tells you, like they explain it, it doesn't make sense. They explain the same words, it doesn't make sense, and all of a sudden it makes sense, and then you know what the words meant, even though the words didn't change, just the way you thought about it changed. Do you know what I mean or no? So like say somebody's explaining something to you, right? And it doesn't make sense. And they explain it to you again. You're like, I don't get it. And then all of a sudden you get it, and then you understood what the words meant. Like you understood what they meant. All that changed was like your understanding. So like this probably might not make sense until we see what it means, and then the words won't change, but you'll understand them better. You'll be like, oh. You'll be like this. You'll say, oh, I see. Oik. Oh, I see. So check it out. First of all, terms, right? Terms are separated by plus, by minus, or by the fraction bar. Okay? So when we talk about all terms, like on this one right here, there's 3 terms only. And this one, though, has 3 on the top and 1 on the bottom, so this has got 4 terms. Right?
Why 3 terms of like?
Because there's 1, 2, and 3.
Oh.
Because this, yep, the denominator or the fraction bar separates terms from other terms, so there's just 1 term in the bottom, but there's 2 on the top because they're separated by this. And over here, there's 1 term, subtracting, that's the 2nd term, that's the 3rd term, and then that's just 1 term in the bottom. So what we're going to find out is that this one cannot be reduced. Oh wait, yes, it can be reduced. The way it's written right now, it can be reduced because there's a common factor. There's something that goes into everything. Do you see? The greatest common factor means what's the biggest number that goes into all of these. So 33x squared, 9x, 3, and 27x to the 5th. Doesn't 3 go into all of those? Right? So 3 goes in there 11 times, 3 times, 1 time, and 9.
Common factor is 3?
Greatest common factor is 3. So I'm going to go ahead and reduce that, and I'm going to write it underneath. So this problem right here is going to be 11x squared minus 3x plus 1 divided by 9x to the 5th. Now, there's 1, 2, 3, 4 terms still, right? 3 of the 4 terms share a factor. But not all. Do you see what I mean? All of the terms have to share a common factor. You're done here because not all 4 terms have a factor in common. Only 3 of them do. So you're done. Because this doesn't have an x. These all have a factor of x, but this one doesn't have a factor of x. So you can't divide an x out.
So if there's only 3 terms that share a factor, then what?
Then you can't reduce it. In order to reduce, all of the terms have to have a common factor. So you are completely reduced when there's not a common factor left between all of the terms.
So we can't reduce.
Cannot reduce anymore. All you need is just 1 term that doesn't have a common factor, and that means you cannot reduce. Yeah. Okay, I'm going to do this one not right, but not wrong either. Ready? I'm going to do it so that it's not, what I'm writing is not incorrect, but it's not going to be complete. Okay, so I'm looking and I see a 3 in everything, right? So that would be 11x squared minus 3x over 9x to the 5th. It's not wrong, but it's not done. So this is a common wrong answer. It's only wrong because you wouldn't get full credit, right? It's just not fully reduced. And the reason it's not reduced is because, do you see all of the 3 terms have a common factor of x? You can divide an x out of everything. Yes, Alexa, or no, Alexa?
No.
No? Well, like over here, there's an x, there's an x, there's an x, but no x.
But then there's like every term has a factor.
These all have a factor of x. So this one's not done. I
But
can reduce more.
You can reduce, right?
Yes. It's not
but
done.
Then why did you put not reduced?
It's not all the way reduced.
Oh, it's not all the way
Yeah, yeah. So I'm going to divide an x out. Now when I divide x out of x squared, what I'm left with is just x to the power of 1. And then minus 3, right? 9x to the 4th. Now it's done. So,
why did you take away the 2 and then the 4?
well, because, check this out. I have x squared, which is x times x. Right? X squared is x times x. I'm not going to write the numbers, just the x's, okay? And x to the 5th. 1, 2, 3, 4, 5. Do you see?
Just crossed.
So I'm dividing x out of all of them. So that goes away and I'm left with just x. This goes away, I'm left with just the number 1 times 3, right? And over here, that's x to the 4th.
Okay, yeah, that's it.
Do you see now?
Yeah, I got it.
I'm glad you asked. It's a good question. That's why this is my favorite class right here. What's up, Jose?
You just take out 1x, right?
Yep.
Yeah, that's me.
X to the power of 1. Out of everything. Edgar's all smiles. He likes this stuff.
No, it's good.
What's so funny about that, Edgar? This is my favorite class.
I
mean, this is
you like saying that.
This is my smartest class. No, Edgar, this is my smartest class, my best looking class. This is it right here. This is it. Alright. So, you ready?